Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study some of the problems. We have to solve some of the problems based on the concept of moment of inertia. Okay, now in the previous session, let us recapitulate the previous sessions, what you have covered. What is the moment of inertia? Moment of inertia is geometrically or mathematically derived. The expression is that I equal to sigma times AR square. Okay, and that I equal to sigma times AR square, where A is sigma A. That means I equal to 1 to N, that is AIRA square. So the generic expression for moment of inertia is I equal to 1 to N AIRI square. This I equal to 1, it becomes AI becomes A1 and RI becomes R1. So A1 R1 square and A2 R2 square and so on. This A1, A2, A3 are all elemental areas, areas of elements, and R1, R2, R3 are corresponding distances of the elements from the line about which the moment of inertia is going to be calculated. And units of moment of inertia is millimeter per 4 or meter per 4. If the area is in meter square, then it becomes the moment of inertia becomes the meter per 4. And if the area is in a square millimeter and the length is in millimeters, that is R1 is in millimeters and A1 is in square millimeter, then the moment of inertia becomes then millimeter per 4. So these are the moments of inertia. So we studied that parallel axis theorem, and we also studied the perpendicular axis theorem. If it is axis about IXX, the moment of inertia IXX equal to sigma times dA, the distance becomes y. If it is about axis XX, that the distance becomes the perpendicular distance, that is the y square. Here, that is IXX is sigma times dA y square, wherever IYY is sigma times dA x square. This IYY means about y-axis and y-axis is the horizontal axis. Then whatever this distance, here it is x square. IYY sigma dA is the elemental area and x square, x is the distance of centroid of that element towards the axis, that YY. And in the case of IXX, sigma times dA y square, sigma times dA y square, the meaning is that dA, where dA is the elemental area and y is the distance of centroid, vertical distance towards axis XX. Okay, this is IXX and IYY. So here we consider dA is the element area of the strip. We consider the strip, the area is the arbitrary area. This arbitrary area is divided into number of elements, strips, vertical strips, each strip having certain area. So that's why here with integration we use, that integration is the sigma here, that's the sum, sigma times dA. We can write it, this equation, that's integral dA x square. Similarly, it is integral dA y square. Okay, this is the manner. In this manner, you have to calculate the moment of inertia of the whole area. Okay, for calculating the moment of inertia of the various areas, we have different theorems are there. There are two types of theorems. Number one, the perpendicular axis theorem. Perpendicular axis theorem. And next one is the parallel axis theorem. This parallel axis theorem is highly useful to calculate the moment of inertia of sections where we want to find out to be found, for especially for composite sections. It is highly useful. Another one is the parallel axis theorem. So now we also discuss the moment of inertia of the individual sections. So moment of inertia of a rectangular section, which is having the dimensions where d is the depth and b is the width. What about x axis? The axis centroidal axis, y is the center vertical axis. this Ixx, that is b dq by 12, that is b dq by 12, whereas Iyy is Iyy equal to, that is dbq by 12. Now similarly for circular, there is a bdq by 12 and dbq by 12, whereas for hollow circular portion, for a hollow rectangular section, the value which is having the outer dimensions are d and b, and the dimensions are d1 and b1, then the Ixx, here the xx and yy are passing through the centroid or center of gravity of this section. So Ixx equal to b d cube by 12 minus b1 d1 cube by 12. Next, Iyy equal to db cube by 12 minus d1 b1 cube by 12. So these axes are passing through the center of gravity of your hollow section here, hollow rectangular section. Okay, in that manner we have to calculate, and we also solve the problems which is having the length and breadth 60 millimeters and depth 80 millimeters, and inner dimensions are b1 is 30 millimeters, depth d1 is 40 millimeters. For such section, the moment of inertia, that's Ixx and Iyy. Here in the sections, Ixx is greater than Iyy. This Ixx is larger y, the d is greater than the b, and d1 is greater than b1. So that's why this Ixx is greater than Iyy. Now we also solve the problems which are exercise problems, which is very simple, and some other problems here coming to the perpendicular axis theorem. Here in this perpendicular axis theorem, if we know that it states that the Ixx and Iyy are the moment of inertia about axis xx and axis yy meeting at about two mutual perpendicularly axis meeting at O. The moment of inertia Izz, if you want, about the axis, that z axis is perpendicular to both xx and yy passing through the intersection, then that moment of inertia about this axis g equal to Ixx plus Iyy, sum of Ixx and Iyy. So there are two mutual perpendicular. We want a third one. Yes, here there are two perpendiculars are there. We want the third axis here about the third one. Here it is the y axis, this is the x axis. Yes, is it visible? This is the y and it is x. Then the third one is required for this is that about z axis, if you want moment of inertia at that plane, that is sum of the moment of inertia vector sum. Here it is moment of inertia about axis x and axis y. So how to derive this, how to prove it? Yes, let us begin. This axis x and axis y here, from the geometry of the figure, from the geometry of this figure, that is r square equal to x square plus y square. If you multiply with elemental area on both left hand side and right side hand, dA r square equal to dA times x square plus dA times y square. That is for elemental. If we make it the integration, the algebraic sum, the sum or toward the section, then sigma times dA r square, that is nothing but Izz, that equal to sigma times dA x square, that is sigma times dA x square, that is Iyy, and dA y square is Ixx. Then Izz equal to Ixx plus Iyy. This is the algebraic sum of xx and yy. Okay, thus we have to find out the moment of inertia about this is the derived expression of a perpendicular axis theorem by considering the area of the plane area. Here it is elliptical section about xx and yy. So this is now Izz, this Izz equal to Ixx plus Iyy. Okay, these are the different sections. We are all revisioning these things what we have studied so that we can understand. Now the coming to moment of inertia of circular section. The moment of inertia of circular section about xx and yy, that equal to pi d power 4 by 64. Okay, we derived expression here, that is pi d power 4 by 64, where d is the diameter of the circle, and the unit for this, here it is the unit for this the solid circular section that is millimeter per 4 if it's the d is in millimeters. And if you want to find out the moment of inertia of the hollow circular section, the outer diameter is capital D and inner diameter is small d. For such type of sections, Ixx equal to Iyy, that is equal to pi by 64 times capital D power 4 minus small d power 4, where capital D is the diameter of the circle, small d is the diameter of inner circle. Now this is the moment of inertia of hatched section. This is not hollow circular, like circular pipe. Okay, and this is the final. Here, if we understand carefully, the Ixx equal to Iyy. For especially, it is exclusively for circular sections, both solid and hollow circular sections of beams. Now here, if we carefully observe, we compare the rectangular section moment of inertia, and if we compare the circular sections moment of inertia, the comparison for rectangular, that circular section moment of inertia, and for circular section moment of inertia, and for rectangular sections moment of inertia MOI, and here it is MOI. Then yes, if we begin here, for here the moment of inertia for circular section both about axis xx and axis yy both are same, but in this case it is not same. Here Ixx equal to Iyy, here Ixx is not equal to Iyy. Rather, here Ixx can be greater than Iyy, or Ixx can be less than Iyy. Ixx can be greater than Iyy provided if d is greater than b, and Ixx is less than Iyy, d is less than b. But here the circular section is dependent on only one parameter, that is the diameter. Whereas for rectangular sections, moment of inertia is dependent on two parameters. One is depth, another one is the width. Okay, that's why it happens for this moment of inertia is not equal. Now here, next we have go for parallel axis theorem, where in this case of parallel axis theorem, if we understand that parallel axis theorem, coming to parallel axis theorem, especially how to find out, we are going to discuss parallel axis theorem. So by using, when to use this parallel axis theorem, first, what is parallel axis theorem? What is parallel axis theorem? Next, when to use parallel axis theorem? Okay, what are the applications of this parallel axis theorem? Yeah, parallel axis theorem, which says that if you want to find out the moment of inertia of any section about a line, about any section of a section about any line, about some axis, suppose here, and the distance of y bar y, yes, is, now this rectangular section is A. This parallel axis theorem states that if you want to find out the moment of inertia about a line PQ, that is IPQ equal to the sum of the moment of inertia of a individual section about its centroid, that is IGX, plus area of the section times distance of the centroid of section and about the line about which we are going to find out the moment of inertia, that is here y, that is nothing but the distance, is the passing through centroidal distance. This is the expression, yeah, this IPQ equal to IGX plus AY square. This y is the distance from, the distance is the centroid here to here. That is, this theorem, this expression is derived from the theorem of parallel axis, that is the parallel axis theorem. Parallel axis theorem says, derived expression mathematically derived, that IPQ equal to IGX plus A bar y square. It is about PQ. If you want to find out RS distance about this line RS distance, now we have to know the distance x, then IRS equal to IGY, because vertical axis YY, IGY plus area into x square. What is here IGY and IGX? I means IGX, what IGY or IGX? IGX means here I denoted with, it refers to the centroid, the moment of inertia of the individual section parallel to axis XX. So IGX equal to, what is IGX equal to? If this rectangular section is having a depth D and width B, that is B dq by 12. What about IGY? That is dbq by 12. What about area? Areas remain same for both the IPQ and IRS. Area A equal to B times D, BD. Now what about Y here? The Y is the distance from that is nothing but Y equal to D by 2. What about X equal to? X equal to B by 2. So this is the theorem here. It is the parallel axis theorem. IRS equal to IGY, IRS about line, that axis IRS, that is IRS equal to IGY plus A times x square, and IPQ equal to IGX plus A times y square. Okay. Now what is the units for this IPQ, IGX, A and bar y square? What is that moment of inertia? Unit for this IPQ is millimeter per 4. Provided area is in millimeters and y is in millimeters. What about this IGX portion? It is in millimeter per 4 plus. What about this area? It is in square millimeter. And what about y square? Y square in y is in millimeters, then it is millimeter square. Then becomes millimeter per 4. Now we check the dimensional, that is called homogeneity of this parallel axis theorem. From left side, RHS units is equal to, and LHS units equal to RHS units. So it is in, okay, there is a unit for moment of inertia is millimeter per 4 or meter per 4. All right. Now it is a simple geometry we considered and applied the parallel axis theorem. Suppose if we apply the parallel axis theorem for a I section, this I section in previous class we considered, here it is, we are going to solve the moment of inertia of the I section, which is having the same width and the same thickness. Okay, for this I section we are going to calculate the moment of inertia, and it is having dimensions of 100 millimeters, and it is 10 millimeter, and again it is 100 and it is 10, and from here to here 100 millimeters, and again thickness is 10 millimeters. Okay, so this I section is having two flanges and one web. It is the flange 1, section 1, flange 1, and we are taking web as a section 2 rectangular with the flange 3 horizontal. The bottom flange is in section 3. Now how to find out the moment of inertia about axis XX and axis YY. First of all, we are going to calculate the moment of inertia parallel to axis, okay, parallel to x-axis, horizontal, IXX. So it is referred to where it is now, the reference axis here, it is IXX. how to calculate. Now this IXX, it is a composite section. There are composite section means the sum of more than one section it is having combination. Then such type of sections is known as the composite sections. How to find out here? Let us first find out the centroid, center of gravity of this section. What is the center of gravity? It is parallel to both XX and YY. It is symmetrical about both. It is the two lines of symmetrical section, and here it is the moment of inertia of this. What is the distance of this x distance from where it is symmetrical section? Now the centroid, here it is. What is the distance? 10 plus 100 by 2, that is 60 millimeters. Okay, now is the centroid of section 1. Next it is the centroid of section 2, and here it is the centroid of section 3. Small g1, g2, and here it is g3. And y1, the y1 distance, y3, what is the y3 distance? 10 by 2, that is 5 millimeters. Yes, y3 equal to 5 millimeters. y2 is the distance of this distance to here, 10 plus, that is 60 millimeters. y2 equal to 60 millimeters. What about y3? Distance of g1 to reference axis xx. Then it is 10 plus 100, 110, 110 plus 5, 10 by 2, 115 millimeters. Now we have to find out the moment of inertia. And for that, for rectangles, for section 1, what is the section 1? Area A1 equal to 100 into 10, that is 1000 millimeter. Y1, yes, Y1, this is Y1. Y1 equal to 115 millimeters. Section 2, A2, what is that A2? Again 10 into 100, that is 1000 millimeters. What about Y2? The Y2 equal to 60 millimeters. Next, section 3, A3, what is that A3? A3 is 10 into 100, then it becomes 1000 millimeters. And what about Y3? The Y3 is 5 millimeters. Now, what is bar Y equal to? Center of gravity of this I section. If you want to find out A1 Y1 plus A2 Y2 plus A3 Y3 by A1 plus A2 plus A3. If you substitute here, then you get the answer. That answer becomes 60 millimeters, bar Y. Next, what to do? Bar Y after calculation. Here, individual section we are going to find out. IXX equal to IXX1 plus section 1. IXX2 about section 2. IXX3. Now IXX1 equal to, what about IXX1 equal to? IGX1 plus A1 and distance of centroid of section 1 to center of gravity distance. What about center of gravity distance? That is bar y minus or bar y minus y1 whole square. Now what about IGX1? IGX1 means B1 D1 cube by 12. What about A1? B1 D1, again bar y minus y1 whole square. We know bar y, we got it as 60 millimeters. Y1 equal to 115 millimeters. And B1, what is the B1? Width 1, that is 100 millimeters. What about D1? That is 10 millimeters. Substitute here IXX1. Now IXX1 equal to B1 BD cube by 12. Alright. That B1 is 100 millimeters. Whatever D1, 10 cube by 12 plus B1 D1, 10 into B1 D1 means 100 into 10 bar y 60 minus y1 115 whole square. It is negative, because of the squaring it becomes positive. Thus we will get it ixx1. What about how to calculate ixx2? Again, ixx2 equal to igx2 plus a2 times bar y minus y2 whole square. igx2 b2 d2 cube by 12 plus a2 b2 d2 times bar y minus y2 whole square. What is b2 d2 cube by 12? b2, if you go back, what is the width of b2? b2 is how much? This b2 is a 10, d2 is 100. b2 d2 is 10 into 100 cube by 12 plus b2 d2 10 into 100 bar y 60 minus y2 60 whole square. 60 minus 60, it becomes 0. That means this term completely 0. Next, what about how to calculate ixx3? ixx3 equal to igx3 plus a3 times bar y minus y3 whole square. What about this igx3? That is b3 d3 cube by 12 plus a3 b3 d3 bar y minus y3 whole square. What about b3 here? Width is 100 millimeters, d3 10 cube by 12 plus 100 b3 100 millimeters, d3 10 millimeters times 60 minus whatever y3 here, that is y 5 millimeters. Now point is that ixx1, this is the value, ixx2, this is the value, this is ixx3. These values, if you substitute in this equation, ixx1, ixx2 and ixx3, will get it the moment of inertia about axis x, ixx, reference axis. Here, very important terms we are going to interpret, we are going to interfere, interpretation, we are going to do it now here. If we consider ixx2, this bar y and y2 both are same. Why? Because this a times bar y square, that is the distance of centroid. Here this term meaning is that distance between the centroidal point, the center of gravity of the total section to distance of individual section. Here bar y minus y1, go back, bar y minus y1. What is the y1? This is y1. Okay. This is the distance of y1 distance from reference axis. What about bar y? This is bar y. We want this section 1 about center of gravity axis, that is xx axis, about this axis distance. That's why what we did, bar y1 minus y bar whole square. Okay, so that is what we calculated about the centroidal axis ixx passing through that. Each individual area of this bdq by 12 about the centroidal axis we have calculated, even though we referred here. Now not yet completed. This is the centroidal, this ixx we want. ixx equal to, okay, ixx equal to igx plus total of this area. Now here about this centroidal axis we calculated about this axis, we calculated the moment of inertia of this axis. Okay. Now, by using which axis theorem? Parallel axis theorem. This bar y minus y1 indicates that the distance of centroid about that axis. No, this ixx is passing through. This is what we calculated. This ixx1, ixx2, ixx3. The sum is which axis we crossed, even though we considered this is the axis, but we considered now by solving the problem, this is the centroidal axis we calculated. About the centroidal axis, we considered the moment of inertia. Now, this is the distance from G3 to this distance, that is bar y minus y3. Bar y minus y3, how it happens? This is the distance of y3. This is the distance of y3, and here it is bar y minus y3. This is the distance. This distance is y3. Now our axis, ixx, though considered here, we calculated first about this axis, the axis which is passing through the centroid, ixx. That ixx equal to the sum of ixx1 plus ixx2 and ixx3. Now, if you want the reference about any axis, the reference of about I-axis, this axis if you want, then Ix1, X2 if you consider, okay. That Ix1, X2 if you want, this is the sum of which axis? Centroidal axis. Then parallel axis theorem says that Ix1, X2, then this Ixx plus total area times bar y square. This Ixx we calculated. We want about this axis. Then what happens? Ixx equal to, we know that Ixx, the about centroidal axis equal to, what is the area? Total area times bar y square. What is the bar y square? That is centroidal distance and total area. Then we'll get it Ix1, X2. Okay. Next, if you want to find out, one more thing is that if our x-axis here, x1, x2 here, the distance now x3, x4 distance. We know this distance of Ixx about the moment of inertia of this individual axis, I section. Then what will happen? Ix3, x4 equal to Ixx is passing through the centroid plus area of the total section and the distance between the centroidal to about this axis. What this axis is, suppose we consider it is a small y. Then what happened? Y plus 60 whole square. Then what about area? This is the total area of the section A1 plus A2 plus A3. Then Ixx we know. What is that Ixx? Just know Ixx equal to Ixx1 plus Ixx2 plus Ixx3. Like that, by using parallel axis theorem, we can calculate the moment of inertia of composite sections. Okay, now let us more discussion about this section. Suppose if there is T section is there. If there is the T section, first about which axis you want to find out? First about this axis we want to find out, or about centroidal axis. If you want a centroidal axis, moment of inertia, the section 1, section 2 rectangle. First we have to find out. Let us begin. Ixx is the axis which is passing through centroid about some centroidal distance. That is xx we want. That is the centroidal distance. First you have to find out centroid, location of center of gravity. Why we have to find out location of center of gravity? That locates where the axis, which axis we want centroidal axis, means we have to find out the first step. First step is that find centroid. Step 1. Step 1 is find centroid. After finding centroid that locates the axis xx or y, which is symmetrical about axis yy, Now we want Ixx. So what is that Ixx equal to? Section 1 and section 2. Ixx here equal to, direct formula I'm deriving here, Ixx1 plus Ixx2. What about Ixx1? Now Ixx1 equal to parallel to x-axis. It is having depth d1, width b1. And here it is depth d2 and width b2. Ixx1 means parallel to individual centroid, parallel to x-axis here, parallel to x-axis. What happened here? b1 d1 cube by 12. I'm talking about Ixx1 part. Next, area 1, b1 d1. What about bar y? What is the bar y? That is centroid. Y bar minus the distance we want. From here to here, this distance we want. How to find out the distance? Is the total distance. This is y1 with respect to reference axis, and here it is y bar. We want this distance, whatever distance, y1 minus y bar. So or y bar minus y1, because it becomes whole square, then it becomes positive term. This is the term related to Ixx1. If you want to find out, plus one portion is over. Next, the second portion is Ixx2 portion. The Ixx2 portion means Igx2 plus what about area? B2 D2 times. Now distance of the centroid of this individual section, it may be here y2. We want this distance. Whatever that distance is, y bar minus y2 whole square. What about Igx2? This Igx2 means B2 D2 cube by 12. Now you'll get it axis XX, which is passing through the centroid. That's the moment of inertia. Now if you want about this x1, x2 parallel axis theorem, then what will happen? Ix1, x2 equal to Ixx plus area into bar y square. What is that Ixx? Just now we calculated by using again parallel axis theorem. What is that area? This area equal to algebraic sum of A1 and A2, total area of the T section, bar y, centroidal distance, the centroid of this T section about x1, x2. Then Ixx1, x1, x2 can be calculated. Okay, in this manner, we have to calculate, we have to use the parallel axis theorem. Okay, in this session, we have revised the previous sessions, and also we use what is the parallel axis theorem, and solve the problems by using parallel axis theorem and calculated the moment of inertia of I section, that is 2 lines of symmetry section, and 1 line of symmetry section, that is a T section. Calculated the moment of inertia of the T and I sections. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.